Good morning, everyone. Welcome back, and thank you for joining us. We're very glad that you're here. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yeah, and today we're talking about this is, I guess, a health topic, right? Has to do with the air that we breathe. And it kind of struck me that these scientists were not all over this originally, because I mean, this, especially in California, we have a really big smog problem. But anyway, let's just talk about it, because
this is really relevant for me today because we're getting smoke from fires in Canada and Minnesota coming over our state, and the Lake Huron is pretty big, and the fires are still drifting over. Or maybe it's in where Lake Superior is and drifting down. But that's crazy. We've got a thick haze of smoke.
And there's nothing you can do about that in your particular case. You're getting secondhand fire smoke.
Yeah, we get alerts that say it's unhealthy to be outside. Shelter in place is what they say.
Yeah, that report that you sent me was very alarming, actually.
Yeah.
The amount of smoke that you guys are getting. So,
okay, here we go. Nitric oxide may play a larger role in city air pollution than scientists previously thought. City air can look clear one moment and turn hazy the next, but the chemistry behind that change is often hidden molecule by molecule. In traffic corridors, near power plants, and around other combustion sources, nitric oxide has usually been treated as a chemical that limits some particle-forming reactions. Researchers from Tampere University and the University of Helsinki now report that under certain urban conditions, it may do the opposite. Would you like to know more?
Yeah, so just a question. How far away from you mileage-wise, roughly, are you from these fires?
From Canada, at least 200 miles. Minnesota, probably 300-400.
Yeah, so that it's all about the wind shifts, right? The wind patterns and the wind shifting. And like I said earlier, there's nothing you can do about that except go inside and hope you don't have some kind of a cooling system that draws air from the outside, like a actual, refrigerated air conditioning system or something. So rather than like an evap cooler that draws air from the outside, just brings it in, because you can't use that. I mean, well, you can, but you're going to get a house full of smoke. So anyway, the finding matters because aerosol particles, tiny bits of material suspended in air, are among the most harmful parts of air pollution. They can enter the lungs, reduce visibility in places such as roads and streets, and influence both weather and climate. Forecast air quality more accurately, scientists need to know exactly how these particles flow in the atmosphere. So we had the other day, about a week ago, we had a fire in Pinion Hills, which, by the way the crow flies, that's about 20 miles from here. And it started out, first got the alarm, it was at about 200 acres, blew up to about 1,200 acres, and then went up to about 2,500 acres.
Dang.
And that was from the morning into the afternoon. And most of that was all caused by winds that we get, crazy winds in the afternoon here, especially in the summertime. And the wind, or the wind direction. And it went from, you could see the fire, the smoke was going straight up and blowing towards the ocean, which had been blowing towards the west. And then that afternoon, it was like a storm was coming in. We had clouds all over our valley. Couldn't see the sun. And you'd swear it would have been a thunderstorm or a rainstorm, but it was all smoke, and it was pretty bad. We didn't have any debris falling on us like we've had in the past from fires that close, but it was pretty alarming. So and again, you got to just stay inside when that kind of stuff happens. So anyway.
For years, atmospheric scientists viewed nitric oxide mainly as a brake on the formation of low volatility condensable vapors. These are gases that can cool, condense, and help build aerosol particles. That view made sense for many chemical systems, but it left an important question open. What happens when nitric oxide meets the kinds of aromatic carbonyl compounds often found in city air?
Yeah, and again, that's another thing we have a problem with here in Southern California. Not as bad as it used to be 30 or 40 years ago, but smog from air pollution, cars mainly. We have a lot of cars in Southern California, or in California period, but a lot in Southern California. So, okay, quote, traditionally, NO, nitric oxide, has been viewed as a compound that limits the formation of atmospheric aerosol precursors. Our results show that it is far more likely to enhance their formation from certain volatile compounds, and that's according to doctoral researcher Shawan Barua from is that Tampere University. Not sure where that is, but
To follow that chemical trail, pun intended, the researchers focused on aromatic carbonyl compounds after they enter the atmosphere from vehicle exhaust, industrial activity, and consumer products. These compounds are volatile, meaning they can easily move into the air as gases, but they can also be transformed by atmospheric reactions.
using advanced laboratory experiments and computational modeling, the researchers identified a pathway that had been largely overlooked. In this pathway, reactions involving nitric oxide can quickly turn aromatic carbonyl compounds into aerosol precursors, the chemical building blocks that help particles form.
Quote, our findings reveal that the chemistry of urban air is more complex than previously assumed. To accurately predict future air quality, we need to understand all the chemical pathways that contribute to particle formation, says Dr. Avinash Kumar from Tampere University.
The result is especially important for cities where aromatic pollutants and nitrogen oxide emissions are often present together. If this newly identified pathway is active in urban atmospheres around the world, it could help explain why models sometimes struggle to predict particulate matter, the pollution made of tiny airborne particles.
Despite decades of work, scientists still do not fully understand how aerosol particles form in city air. Professor Matti Rissanen from Tampere University argues that one reason may be that some important reaction chains have been left out of atmospheric models.
Quote, sequential oxidation reactions between common air pollutants, such as those highlighted in the study, have been missing from the existing model chemistries and may go a long way towards explaining why predicting urban aerosol loads has been so difficult. And that's according to Professor Matti Rissanen from Tampere University. I don't know where this Tampere University is. He believes the findings will help scientists improve atmospheric models used to predict air quality and assess the impacts of air pollution on human health and the climate. I don't know. It's weird because I think this is kind of stuff's been going on in the States here for a long time. So I don't know where this place is, but I mean, they've been studying air pollution in California specifically, but all over the place, right? Even in your neck of the woods, like the Detroit area, with all the factories and stuff.
Pretty much every built-up area, Phoenix, Houston, Austin,
right,
Dallas.
A lot of areas that have where there's a lot of factories. There's not a lot of factories in California anymore because they closed a lot of them down, but where they've made cars and chemicals and plastic products, a lot of that kind of stuff. And then they would just dump the pollutions into the air or dump it in the water. I think a lot of that has been kind of cleaned up, right? Because we have that Environmental Protection Agency that loves to, zero in on companies that are trying to do that and stuff. So, and then the car companies trying to make everything super clean, the exhaust coming out with catalytic converters and special mufflers and all kinds of junk. So, yeah, they've really been working on that here in the States. I don't know where this is, but be interesting to find out, I guess. But anyway, good story. Oh, maybe it's in Helsinki, which is what? That's Finland, right?
Yeah, Finland.
There you go. Said that at the beginning. Tampere University and the University of Helsinki. So maybe it's in Finland. So maybe they don't have the issues that we have, or didn't think they had the issues that we have had over here. So anyway, there you go.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care. Thank you.